Bismillahirrahmanirrahim. Today we are going to speak about the determinants of the matrices. Before giving any definition or any exercise about the determinants, let's speak about the linear equations, and from that point we can move forward to the determinant of the matrix. Now, if we are given a linear equation 2x equal to 4, and we need to solve for x, we'll say that x is equal to 4 divided by 2. We divide by the coefficient, I will have x equal to 2. So for the linear equation, to find the value of the variable, we divide by the coefficient of x. But if we have a matrix form, A, x equal to some constant b. As we said before, the matrices doesn't have any division. The division operation is not valid or applicable for the matrices. We cannot say cannot be say x equal to b divided by a. This is not true. But we have another form or technique to solve for the linear system if we extend in the matrix form. Usually we are saying that x is equal to a inverse multiplied by b. So we are speaking about the inverse of a matrix, multiplicative inverse of the matrix. So it is not division, it is multiplication of the inverse of the given matrix if it has an inverse. So in this part, we are going to speak about the inverse of a matrix. But before that, we have to define the determinants, because sometimes we find, or we can find the inverse of the given matrix by finding the determinant of that matrix. So let's start by defining the determinant. With 2 by 2 matrix, the determinant of a matrix A of order 2 is given by, like, absolute value of A is equal to A sub 1, 1, A sub 2, 2 minus A 2, 1, 2, 1, and A 1, 2. It is the main diagonal minus the other diagonal elements. So that is one we call the main diagonal of the matrix A. It is A sub 1, 1 multiplied by A sub 2, 2 minus A 2, 1, A 1, 2. This will give me the determinant of the matrix. As a direct application for this definition, let's have these examples and let's find the determinant for the given matrix. Number 1, I need to find the determinant of the first matrix. 2, minus 1, 3, and 5. And the notation for the determinant given like an absolute value. Now the determinants will be equal to, for the first matrix, the main diagonal 2 multiplied by 5 minus the off diagonal, which is a 3 minus 1. That will give me 10 minus a 3, which is equal to minus with minus is a plus. So I will have 13. Now the determinant for this matrix is equal to 13. As I said, that the determinant is used to find the inverse of the matrix, and also sometimes to determine whether the matrix has an inverse or not. If the determinant equal to 0, then the matrix doesn't have an inverse. If it is not equal to 0, then the given matrix has an inverse. Now in the next example, I need to find the determinant of this matrix, which is 0, minus 83, and 4. Determinant in this case will be 0 multiplied by 4 minus 3 multiplied by minus 8, which is equal to 0, minus 24, which is equal to 24. So the determinant for this matrix is equal to 24. Next one, determinant of this one is 0 multiplied by minus 2 minus 0 multiplied by 9. That will be 0 minus 0 is equal to 0. Now, if the determinant equal to 0, We call this matrix singular matrix. Singular matrix means this matrix has no inverse. If the determinant is equal to 0, then the matrix is called a singular matrix, or there is no inverse for the given matrix. Let's move to the next point in this lecture. Product property of the determinants. If A and B are square matrices of order n, I have two matrices A and B, and most of them are square matrices. Square matrices means the number of rows equal to the number of columns, n by n. So we call it square matrix of order n. Then the determinant of the product AB equal to the product of the two determinants A, or the determinant of A multiplied by the determinant of B. So the determinant of the two matrices equal to the product of their determinants. Now to speak about the inverse of the square matrix. If A is a square matrix of order n, then A has a multiplicative inverse if and only if the determinant of A is not equal to 0. So A inverse equal to 1 over determinant of A. So the matrix A has an inverse. Inverse, it means that A inverse times A will give me the identity. This is the identity. And we defined the identity before. It is a matrix given by 1 in the main diagonal and 0 everywhere. This is the identity matrix. So A inverse times A equal to I, and also A, because we know that the matrices or the product of the matrices is not commutative. So also A times A inverse must be equal to the identity. So if these two conditions are satisfied, then we said that A is an A inverse, or A has an inverse. But to have an inverse, the determinant must be not equal to 0. And also the determinant of the inverse will be 1 over the determinant of the given matrix A. Now, if we are given a 2 by 2 matrix, so with that given matrix, which is A, B, C, and D, then the inverse will be given by 1 over, we say the main diagonal is A times D minus B times C, multiplied by dA. We swap between the main diagonal and change the sign of the other element, will be minus C minus B. This will give me the inverse of a 2 by 2 matrix. So if A is given by 2 by 2 matrix A, B, C, D, then the inverse is 1 over the determinant. Sometimes we can write it as 1 over delta, which means the determinant. D minus B minus C and A. For example, suppose that we are given these matrices. First one, I have 2 minus 2, 3, and minus 2. And I need to find the inverse if it exists. So in the first step, I will find the determinant of the matrix A, or of the given matrix. 2 minus 2, 3, and minus 2. The determinant is equal to main diagonal first. That will be 2 times minus 2 minus 3 times minus 2. Which is equal to, this is minus 4 minus 6, that will be 4 plus 6 equal to 10. Since the determinant is not equal to 0, then this matrix has an inverse, which is equal to, now A inverse is equal to 1 over determinant times, we will swap between these two. So I'll have minus 2 and 2, and change the sign of the other element. That will be minus 3 and plus 2. That is minus 2, or I can write it as 1 over the determinant, which is 1 over 10, multiplied by minus 2, 2, minus 3, and 2. So this is the inverse, or more detail will be minus 1 over 5, minus 3 over 10, and 1 over 5, and 1 over 5. So this is the inverse of the given matrix, if I call it A. So put that in the second one, I will call this one B. Let's find the inverse for this matrix B. Minus 2, 3, 2, and 4. And 4, not minus 4 there. And I need to find the inverse for this one. So finding the determinant as in the first step, I will have the main diagonal. It is minus 2 multiplied by 4 minus 2 times 3, which that will give me minus 8 minus 6 equal to minus 14. And since it is not equal to 0, then this matrix has an inverse. So B inverse 1 over delta. What is it? Delta determinant multiplied by swap between this element minus 2 and 4. I will have 4 and minus 2, and change the sign of the other element, that will be minus 2 and minus 3. This will give me 1 over 14 multiplied by 4 minus 3 minus 2 and minus 2. So this is the inverse of the given matrix or given 2 by 2 matrix. If it is 3 by 3 matrix, we have different techniques to find the inverse for the matrix. So sometimes by doing something called the row operation method or Gaussian elimination or whatever, or you can use something called the minor or the cofactor to find the inverse for the matrix. But since it is 2 by 2, we can apply this technique to find the inverse for the given matrix. If it is 2 by 2, we find the determinant, then the inverse will be 1 over the determinant multiplied by what's called the adjoint of the matrix. Just swap between the elements in the main diagonal and change the sign of the other elements, and that will give me the inverse matrix.